So for your warm-up, each one of these is something you can do with what we learned yesterday, but each one of these is a little tricky. Last class. Each one of these has a little trick to it. They're not straightforward, right? So you need to think about what's missing, what's the trick, and then proceed from there, okay? You can't just jump right to magic X. There's something else that's going to go on here, okay? So that's your little hint to get you started. Go ahead and work on this, all right? I'll come around and check your homework, and then we'll get going. We got a full day today, so okay. All right. So like I said, on each one of these problems on the warm-up, there's a piece missing. There's something extra that has to be done. You can't just dive into magic X to solve these. You have to be able to think about, what's keeping me from doing magic X, right? So if you take good notes right now on these three examples, right, and you write down which type it is, you will have an example in your notes that you can then go back to anytime you get a problem like this, okay? So for instance, what makes this possibly tricky? Like, what's missing here? C, right? We know y equals ax squared plus bx plus c. So what we're talking about is a missing c problem, right? We're missing our c value. So what we are about to do is what you can do anytime you're missing your c, okay? And we'll show you, there's going to be two ways you can do this, right? So, all right, so what's one thing we could do if we're missing our c? Yeah?
Plus 0?
Yeah, we can just add a c of 0, right? It doesn't change anything, it just puts something in that c position. So now we can actually use our strategies that we've learned. And our strategies say, go magic X, right? Put c on top, b on the bottom, two numbers that multiply to give me 0, add to give me 5.
5 and 0.
5 and 0. And it's always going to be, when you get 0 on the top, one of them always has to be 0. So it's always just going to be 0 in this number, right? So this becomes 0 equals, and then x plus 0, x plus 5. All right, and then this is where you could have picked up with what we learned last class, which if two things multiply, zero product property, right? Two things are multiplying to give you 0, one or both has to be 0, right? So you just say, okay, either this is 0 or this is 0. And you set up new equations where you set them both equal to 0. And then you solve each equation. Oh, I did put plus there. Equals. Yeah?
Can you just write like x parentheses, or do we have to put 0?
In this case, you could have just wrote x, because x plus 0 is just x. So yeah. And so you get x equals 0. That's done. You don't even have to do anything there. And then over here, x plus 5 equals 0. So I would minus 5 on both sides. And I'd get x equals minus 5, right? Now what we just found are the two values, 0 and negative 5, that if you plug them into this first equation, would make it true. It would make it 0. 0 squared plus 5 times 0 is 0. Negative 5 squared plus 5 times negative 5 is 0. Okay? So that's what we found. That's why we did it. Now, there's another way you could have done this problem. You could have said, well, if I have 0 equals x squared plus 5x, right? Then what do I know goes into both x squared and 5x? Like, what goes into x squared but also goes into 5x? What's the GCF here? X. You could GCF x here, right? So you could say 0 equals x parentheses. Well, x squared divided by x is x. 5x divided by x is plus 5. And I got to the same thing, but I didn't use magic x. So I was able to get there a little quicker, right? Same deal. I would say x equals 0. X plus 5 equals 0. And then that means x equals negative 5. Same answers, right? So those are your two options whenever you're missing your c value. You could factor out the x, or your GCF, whatever it is, or you could put in a 0 for c and then use magic x. Okay? That was your first example. All right, so your second example, or second warm-up, I should say. Well, if this was missing c, what's that missing? It's got no bx value, right? It doesn't have the middle one, so this is missing your bx. And again, you're going to have a couple options here. First one is just like here. Well, if you're missing it, put one in, right? 0 equals x squared plus 0x minus 36. So where there was no bx, I put 1. But I just put 0, and it doesn't really change anything. I can magic x that. I got negative 36 and 0 on the bottom. So two numbers that multiply to give me negative 36, and they add to give me 0. 6 and negative 6. And that's always going to be the case when you're missing your bx. You're always going to get the same number, but with a positive and a negative, because you have to add to get 0. Okay? So this becomes 0 equals x minus 6, x plus 6. You pull it apart, and that means x equals 6 and x equals negative 6. You don't have to do this thing every time where you minus 5 from both sides. I'm just doing that to show you why this works. If you want to jump to this, I know it has to be 6. I know it has to be negative 6. You can. If you need to do that every time, do it. Okay? Now, I told you there were two ways. The second way is to say, well, I know if I have 0 equals x squared minus 36, back when I first learned about solving for x, we just tried to get x by itself. That's all we did. We just moved things away from x and got x by itself. So you can do that. You can add 36 to both sides. You get 36 equals x squared. I still want to get just x, so I square root it, right? Square root, and I get x equals plus or minus 6, because both 6 times 6 is 36 and negative 6 times negative 6 is 36. That's the same answer. I got 6 and negative 6 plus or minus 6. Those say the same thing, right? So those are your two ways to do that problem, okay? Now your last problem on your warm-up, what was the issue here? There wasn't anything missing, but we had a little extra. Our a value is not 1, but what is it?
2.
Okay, and what is it in this situation? It's a GCF. It's a greatest common factor. So if you have a GCF, this is a GCF problem, the first thing you got to do is factor it out. Okay? So you would say, okay, 0 equals 2, big parentheses, and then divide everything by 2. You just got to pull it out, right? If you can. Sometimes you can't. We'll talk about that today. X squared plus 10x minus 24. Divide everything by 2, right? Now I can magic x what's on the inside. I got minus 24 on top and 10 on the bottom. So two numbers that multiply to give me negative 24, and they add to give me positive 10. 12 and negative 2. So that's what goes in here. So I have 0 equals 2 times x plus 12 times x minus 2. Now, how do I solve this? So you don't need to distribute the 2 first. So this is where a really good understanding of the zero product property helps you. Before, we just had a number times a number is 0. What must have been true? Well, either that's 0 or that's 0, right? Now I have 2 times the number equals 0. So what still needs to be true? Either this is 0 or this is 0. The 2 is kind of irrelevant here. It's going to be 2 times 0 times something, or 2 times something times 0. The 2 doesn't really do anything. So I don't even worry about the 2 at this point. I ignore it, and I say x plus 12 must equal 0, and x minus 2 must equal 0. Those are the two things that would make this 0, right? Either that's 0 or that's 0. 2 can't be 0, so I don't need to worry about it, right? So now I just do the math. Minus 12 on both sides. X equals negative 12. And plus 2 on both sides. X equals 2. And those are the two values that if I plug them into the original equation would make everything 0. Would make this true. Okay? Okay, so any questions on the warm-up on any of those 3 problems, anything that we just did? Yes?
So the 2x values at the bottom are final answers.
Yes, those are our solutions. Remember what a solution is. A solution is something that makes an equation true. What we're saying, x equals negative 12, means if I put in negative 12 right here and right here into these 2x values, it would make it all equal to 0. 2 times negative 12x plus 20 times negative 12 minus 48, all of that would be 0. That's what I just found out. Okay? I found a solution that makes the equation true. There also are x-intercepts. Okay? All right. Any other questions? That was a good question. All right. To the homework. Okay. So we need to talk about factoring when a does not equal 1 and there's no GCF. So, for example, this problem right here, right? Our a is what in that problem? 2. And is it a GCF? No, we know that because you can't divide everything here by 2, right? So we need another strategy. And I'm going to give you 2 today. And I'll be honest, they're a little confusing. And students today have been like, huh? Okay? That's okay. We work through that confusion. Through practice, it becomes, oh, I get it now. It clicks, right? But we got to stay locked in, and we got to be taking good notes, and we got to practice tonight for homework. Okay, so our first step, if a is not 1, is we check for a GCF. So first thing I want you to do is always check for a GCF. Because I don't want you to have to do what we're about to do if you don't need to. Check for a GCF and use magic X if there is one. Like, that's your quickest way if you can do it. If you don't check for it, you might do a lot more work than you need to do, right? Unless you really love the things that we're about to do today, okay? So, let's say you've checked for a GCF, like in this problem, there is none. Now you have to move on to your other method. So, if that doesn't work, then your 2 options are reverse box or rainbow. Those are your 2 methods that we're going to talk to you about today. Okay? Reverse box or rainbow. All right? We'll start with the reverse box. I'll show you an example, and then we'll talk about the steps at the end. Okay? Now, for remembering what a box is, before we do a reverse box, let's talk about what a box method is. If you had like x plus 3 times x plus 2, right, you would make a box, right, and you'd put x and plus 3 here, and you'd put x and plus 2 here, right? And then you would fill in the box. You would fill in the boxes. You would go, okay, x times x is x squared, x times 2 is 2x, x times 3 is 3x, 3 times 2 is 6. These ones always come together, and I get x squared plus 5x plus 6, okay? That's when we're trying to go from intercept form to standard form. But now we'll have standard form, and we want to go to intercept form. So we're going to use this in reverse. Now, what do we notice always goes in the top left? The squared. What always goes in the bottom right? The C. We're going to use that to our advantage. That's going to be our starting point, okay? So what we're going to do now is reverse box method, okay? So what we're going to do is we're going to build a box. And there's pieces we can fill in, right? We're trying to find the things on the outside, but we got to fill the inside in first. What do you think we could fill in here? We know that this is the equation that's going to end up in there. What's always going to go here? The x squared. So let's put it's our ax squared. Let's put our ax squared there. And what always goes on the bottom right? C. So let's put 25. Okay. The next thing you're going to do is build an extra box in the top right corner. It's a new box, and what we're going to put in there is our bx. Because what we need to figure out is these two pieces, and that'll be just a little reminder of what they need to add up to. They need to add up to 15x somehow. Okay? So we're going to put a little box over there. Now we got to do some side work. We're going to find a times c. Okay? So in our case, what's our a? And what's our c? What is 2 times 25? 50. Okay. So that's our new target. Now, what I mean by target is we need to find, and this is going to be very similar to Magic X, but there's a reason I'm not setting it up that way. We need to find two numbers that multiply us to give us 50, and they have to add to give us 15. So that's our target, and that's our target. Two numbers that multiply to give me 50 and add to give me 15. 10 and 5. You see that, right? They multiply to give me a times c now, and they add to give me b. Now, those are what's going in those other boxes. So I put 10x here and 5x here, or vice versa. It doesn't really matter at this point. Okay? Now, we filled in the box, right? It's time to reverse it. Remember, originally we would have something out here and something out here, and then we fill in the box. We filled in the box first. Now we're going to pull stuff out of it, okay? So what we need to do is think to ourselves, okay, if a number is going to go here, it has to go into both of these. So we're actually going to GCF these two terms. What goes into 2x squared and 10x? Not just 2, what else? 2x, because x goes into both of those, 2 goes into both of those. So 2x is going to come out here. And what must I multiply 2x by to get 2x squared? X. So I know x goes here, right? And I just start filling in the pieces. Okay, 2x times something gives me 10x. 5. So this must be plus 5. And then x times something gives me 5x. 5 again, so that must be 5. And I've just filled in all the pieces I need, right? Now I know that this equation right here can be rewritten as y equals 2x plus 5 and x plus 5, right? And you can check your work. If you FOIL this back, it would be 2x squared plus 5x plus 10x plus 25, and that would give me everything I needed for my original equation. And now, what can I do? Because I was being asked to solve it, right? So I want to set it, what? Equal to 0. So 0 equals 2x plus 5, x plus 5. And I pull it apart. I know that 2x plus 5 equals 0, and x plus 5 equals 0. So I minus 5 on both sides here. 2x equals minus 5. Divide by 2, divide by 2. Here I get x equals negative 5 halves. On this one, I minus 5 on both sides, and I get x equals negative 5. And I found my two solutions.
How do you do that? Wait, so
I'll zoom in here. So remember, this is just like in our warm-up. Once we get to this point, we know that either this is equal to 0, 2x plus 5, or x plus 5 is equal to 0, or both. So we set them both equal to 0, right? And then we solve. So minus 5 on both sides, divide by 2 gives me my answer. Minus 5 on both sides gives me my answer. Yeah?
Why do you divide by 2?
Because I end up, when I minus 5 from both, if I have 2x plus 5 equals 0, and I minus 5 on both sides, I end up with 2x equals minus 5. I want x by itself. So I got to divide by 2, and then I'll have, and I just went over here. I get x on one side, and then minus 5 divided by 2 on the other side, or minus 2.5. Okay? All right. So our steps, well, what did we do there? What did we do? We first built a box and then plug in in ax squared and c, right? That's what we did first. We did ax squared and c. And we put an extra box on it. Then we find a times c, right? And then we're going to find, someone's water's leaking? Thank you. Just be careful. We'll clean that up in a bit. All right, so we found a times c, and then we're going to find two numbers that multiply to a times c and add to b, right? Put those in the box. Plug into the box. Then we factored out. And then we solve for x. Okay? Now, you'll get an opportunity to practice this tonight, and in a moment, I'll give you one to do on your own. Before we do that, I want to show you the other option, because you have two options, okay? I have a feeling most of you will choose this option, but the other option is quicker. It's just a little more confusing. Yeah?
Is there like a situation where we can only use one, or are we always going to be able to use both?
Solutions?
Like, so you're showing us the box method and the rainbow. Like,
Oh, I see what you're saying. No, you should be able to use both in every situation. Okay? All right. So that's your box method, right? And these methods are going to have, or reverse box method, they're going to have some similarities because we're trying to do the same thing. So some of the steps are going to be a little bit of the same. But there's a different step in here that you'll see is a lot different, okay? So, anybody still writing? Yeah, okay. Mm-hmm.
Can I take it today?
Take what?
The test after school.
You can, yeah. How late can you stay? It's a long test.
She's just gonna sit in the car.
Yeah, sure.
Thank you.
All right. So this other method, we'll call it the rainbow, and here's why. The very first thing you do is draw a rainbow. What? Draw a rainbow above your equation from A to C. Because the first thing we got to do is find A times C. Okay? It's like I said, there are some steps they have in common. We find A times C. That is a key component in both the steps. So for us, that would be what? 5 times 6, which is 30. And then we do the same thing we did before. We say, okay, 30 must equal something times something, and then those same things, so same numbers have to add up to negative 13. So it's very similar to magic x, but A times C instead of just C. Okay? Now, what two numbers would multiply to give you 30, but add to give you negative 13? Yep, negative 10 and negative 3. Negative 10 and negative 3. That works for both, right? That wouldn't add to give, that wouldn't, wait, negative 15 and positive 2? That would give you negative 30.
Oh, okay.
All right, so watch closely. This next step is a little like, huh? Okay, so what we're going to do is we're going to rewrite the equation by breaking apart the bx, okay? So I'm going to say y equals 5x squared, but instead of minus 13x, I'm going to break it apart into the two pieces that I found. I'm going to say minus 10x minus 3x plus 6. Okay? So all I did is I turned negative 13x into negative 10x minus 3x, which is the same thing. So I haven't broken any rules, right? Now, why did I do that? Because I've created what's called grouping, a grouping situation. Okay? There are two groups here. We have a group here, and we have a group here, right? 5x squared minus 10x minus 3x plus 6. Those are two groups, right? Now, I can GCF both of these groups. Each of these groups has its own GCF, so that's what I'm going to do. I'm going to say, okay, what goes into both 5x squared and negative 10x? Think both numbers and letters. 5 and x goes into both of those. So 5x, and then 5x squared divided by 5x is just x, minus 10 divided by 5x is minus 2. All right, now I'm going to do it again. I have minus 3x plus 6. What goes into both? Well, this time they don't have an x, so it's just going to be a number this time. So minus 3x and 6, minus 3 goes into both. Yeah?
You divided 5x squared and negative 10x to get x minus 2?
Yeah, I divided by 5x, because this divided by 5x is this, and this divided by 5x is this. I just GCF this green section. And then I'm going to GCF the other one. So minus 3 is going to get pulled out of this one. So minus 3x divided by 3 is x. 6 divided by minus 3 is minus 2. Now, what do we notice? X minus 2 is in both situations. Now, before we do the next step, I want to take you to the side for a second and say, if I had 5x times y minus 3 times y, and I told you GCF that, what could you pull out of both? Y. You'd say, okay, y times 5x minus 3, because this was next to both of those being multiplied, so you were able to pull it out front. What's my GCF in this whole situation? Let's see if you can get this one. X minus 2 is now my GCF. They're both being multiplied by x minus 2, so I can divide them both by x minus 2, right? And this is where it gets a little confusing, so that you can either understand with this part or just remember, you take the thing they had in common, the x minus 2, and you put that out front. And then the other pieces are go in the other spot, 5x minus 3. Okay? So you take the group that you found, put it out front, and then 5x and minus 3 go in the other one. And now you factored into factored form. Yeah?
Say that again.
So you're gonna, when you do this grouping, when you do GCF here and GCF here, you're always going to get the same thing twice, right? That comes out front, and then the other parentheses is everything else. So 5x and minus 3.
Do we do it squared? Or?
Nope. Because all you're doing is this. You're GCFing it. You're saying, I have 5x times something minus 3 times something. So I divide them both by that something and then put them in parentheses. I divide these both by x minus 2. And then what gets left? The other things are what's in your parentheses. And I will admit, that is a high-level, kind of confusing thing. So if the reverse box is your choice, that's fine. But this will be quicker if you can get through it, okay? Or if you just remember the steps and you can knock it out. And at some point in the year, we will need to do this for other problems. So it might be good to practice it, okay? All right, so now I have this. I set it equal to 0. 0 equals x minus 2 times 5x minus 3. So both of these get set equal to 0. X minus 2 equals 0. 5x minus 3 equals 0. Plus 2, x equals 2. And then this one, minus 3, 5x equals minus 3, right? Divide both sides by 5. And I get x equals negative 3/5, right? And Now I have the two answers. The two things that if I plug them into that, I would get 0. Right? That's what we're always looking for. Is what are our solutions to this? Question.
You subtracted 3.
Oh, I meant, thank you. Plus 3, plus 3, plus, plus. Yeah, so just 3/5. Thank you. Okay, now I want you to try both these things. So try them on the next page. We're not going to get through the whole page of notes today, so don't worry about the bottom of the next page. Just do the problems on the top. Try reverse box. Try this method, rainbow method, and then I'll go over them at the end of class, and we'll be done. And then I'll hand out homework while you're working on that. Oh yeah, I'll give you some steps. Okay. You can start working if you want, but I'll write down some steps here. So first, find A times C. Then find numbers that multiply to A times C and add to B. Next, rewrite your equation and pull apart your BX. Okay? Then you factor by grouping. Which factor by grouping means GCF both group, pull out a GCF in each situation, and then solve for x. Okay? Yeah. All right, so go ahead and work on those two problems while I hand out your homework, and then I'll give you the answers in a second. All right, I'm going to show you the solutions super quick. All right, I know this is going to go quick. All right, reverse box, right? So I make a box. Stop my video. All right, so we've made our box, right? We put ax squared here and c here. And then we do a times c, which is 2 times -6, which is -12. Two numbers that multiply to give us -12. And they have to add to give us -1. Right? So that would be -4 and 3. That works for both situations. So that's what goes in here, -4x and plus 3x. Okay? So then we factor out. So what goes into both of these? Well, 2x would go into both of those. If that's 2x, this must be x in order to get 2x squared. X times 3x, this must be 3. 2x times something is -4x, that must be -2. And, oh, I forgot to put this up here as a little reminder. Yep, they add up to that. These multiply to that. We're good. So this gives me 2x plus 3 times x minus 2. Set that equal to 0, and then you solve from there. Okay, for this one, okay, so the first thing I want to do is find a times c. In this case, that's 2 times -27, which is -54. So that's my target. -54 equals something times something. So it also needs to add up to -3. So two numbers that multiply to give me -54, add to give me -3. That would be 9, sorry, whoa. That would be -9 and 6. That works for both situations. I pull apart the middle. So I say y equals 2x squared. And then I would have minus 9x. Well, actually, I'm going to do the plus 6 first, and you'll see why. Plus 6x minus 9x minus 27. The reason I did the 6 first is because that works with the 2 for grouping, and the 9 works with the 27. If I did them the other way, I would run into trouble. now I factor by grouping. So I GCF both situations. So y equals 2x comes out of both of these, and I get x plus 3. And then minus 9 comes out of both of these, and I get x plus 3. The x plus 3 comes out front, and then the other two pieces go in the back. I factored it, I set it equal to 0, I solve. Okay? All right. So, let's see if we have any questions on the homework. We're going to move straight to the back of the homework because the front was just kind of a review of graphing, right? Like on the front, you just needed to graph, and that was last unit, and then whatever your x-intercepts were, that's your solution, right? So you're just finding x-intercepts on the front. We've been through that a lot, right? You just would graph it, whatever your x-intercepts are, that's the solution to your quadratic, right? On the back, you had to do solving by factoring. So either it was already factored and you needed to think about zero product property, or you needed to use magic x, maybe sometimes a GCF, to factor it out, then solve. Okay? So which problems would we like to see, if any? Yeah? So like I said, on the front, you're just graphing. So you just have to use everything we learned in the last unit, negative b over 2a, find your vertex, stretch from there, and then you would have whatever your x-intercepts were. So this would be negative 8 over 2. So that would be negative 4. Plug in a negative 4. Negative 4, 0. Okay? You get your vertex by negative b over 2a. Then your stretch tells me 2 over 1 up 1, over back 2 up 4. And then if it's asking you for your solution here, well, there's only one. There's only one x-intercept. So the answer would be x equals negative 4. That would be your answer. Okay? But the other stuff is from the last unit. Okay? All right. On the back, what would we like to see? 8. Okay. Anything else? 14. Okay. Anything else? Okay. So we'll talk about 8. Now, in order to talk about 8, I want to talk about 7 first. Because could you do 7? Did you get 7? Not sure? Okay. Because in my classes today, most people are like, I can get 7, but 8, I'm not sure. To me, that means you remembered something that I did and you could repeat it, but you didn't understand why. And I'll explain, and that's okay. That's what we do usually. We try to replicate, and then we try to understand. Okay, so when we're doing these, we usually just go, okay, well, if n minus 5 times n plus 1 is 0, well, I know my two answers are, well, I remember the teacher flipped the sign, so it must be 5 and negative 1, right? And you would be right. Those are the answers, right? But why are those the answers? They're the answers because that's what makes this 0 and that's what makes this 0. And you do that by saying, well, n minus 5 must be 0 or n plus 1 must be 0, right? You're using the zero product property. You know that one of these two things, this or this, has to be 0 for that to be 0, right? So you set these equations up, and then you add 5 to both sides, and you get n equals 5. And that's your answer. And then here, you would subtract 1 from both sides. And you would get n equals negative 1. And that's your other answer, right? And it gets you these answers. But if all you remembered is he usually flipped the signs and you don't remember the reasoning, when we get to 8, it makes it a little tricky because you can't just look at it and know the answer, right? Because in 8, well, one of them, maybe we know the answer, right? We know B is going to be two things. What's one of them pretty clearly? Maybe not as clearly. What would make this negative 5, right? Because we know negative 5 plus 5 is 0. That would make that 0, therefore everything would be 0. The problem is, what would make this 0? Maybe you can't do that in your head. I'm not asking you to, right? Think about the question you're asking yourself. You're asking yourself, when would that be 0? Well, set up that equation. Say to yourself, 3b minus 7 has to be 0, right? This has to be 0. Okay, let me solve that, right? If I gave you that two-step equation in our first unit, you could solve it. What would you do?
You would do +7.
Well, plus 7 on both sides. You get 3b equals 7, and then you would divide by 3. B equals, and I would just leave it as a fraction, 7/3, right? So that's our other answer, 7/3, right? Sometimes we can't just see it. We have to be able to solve for it, okay? Now, I said that these are the things that make this true, right? Well, -5 is clear. -5 plus 5 is 0, right? 7/3 times 3. What would happen?
21 over 3
Which is
plus 7.
7. So it would be 7 minus 7, which is 0, right? So it does work. It does give you a solution. It's just not as clear to see, so you want to do the work to figure it out.
You're still just flipping the sign.
Yes, but there's a little bit more work that needs to be done here because you needed to divide by 3 as well.
So for the bottom b equals, if we would have put 7, that wouldn't have counted?
No, because that would be 3 times 7, which is 21 minus 7. That doesn't make that 0. Okay? Good question, though. All right, so that's your process. When you're already factored, you just do this. But with these other problems, you have to factor them yourself. So let's go to 14. Okay, so the trick about 14 is typically we said we want all of this to be equal to what? 0, right? That's when we can use our property. That's when we can do things, right? But this isn't equal to 0, right? But we wish it was. So what could we do to make it equal to 0? Minus 7 on both sides, right? If I minus 7 here and I minus 7 here, this will become 0, this will become something else, and then I can do my work. I can work my magic, right? So this gives me x squared minus 4x, and this would be minus 32 equals 0. Now I have a situation where I can use my magic x, I can find my answer, right? So minus 32 on the top and minus 4 on the bottom. Two numbers that multiply to give me negative 32 and add to give me negative 4. It's negative 8 and positive 4. Okay? So this becomes x minus 8, x plus 4 equals 0, right? Now I just say, okay, what would make that true? X equals 8, and again, I'm skipping a little here. X equals negative 4. These are the two things that would make that true. If it was 8 minus 8 or negative 4 plus 4. Okay? Does that make sense?